Dear students, today we are going to discuss about two important aromatic electrophilic substitution reactions. That is about nitration and sulfonation reactions. So let us continue with nitration reaction. So what is nitration reaction? Replacement of a hydrogen atom in a molecule by a nitro group, that is NO2 group, is called nitration. So from benzene, one of the hydrogen atom is getting replaced by a nitro group from nitric acid and producing nitro substitute benzene, that is known as nitration reaction. So when benzene is treated with a mixture of nitric acid and sulfuric acid at 60 degrees Celsius, we are getting nitro substitute benzene, that means nitrobenzene. So in this reaction we are using a mixture of nitric acid and sulfuric acid. Nitric acid can be represented as HONO2. So when benzene reacts with a mixture of nitric acid and sulfuric acid, hydrogen, one of the hydrogens from benzene will react with OH from HNO3 and water molecule will get eliminated and nitro group will get electrophilically substituted on the benzene ring. This is nitration reaction. Now let us know about the mechanism of nitration reaction. Actually, mechanism involves mainly three steps. First step is the generation of the electrophile. Second step is the formation of the rhenium ion or carbocation or sigma complex. Third step is the loss of a proton from the sigma complex or carbocation. So we know that in nitration reaction there involves a mixture of nitric acid and sulfuric acid. Here sulfuric acid acts as an acid and HNO3 acts as a base. HNO3 accepts a proton and thereby acts as a base from sulfuric acid, and this protonated form dissociates to yield the electrophile nitronium ion NO2+. So in this case sulfuric acid acts as an acid because it is a strong acid and it donates a proton to HNO3. Then HNO3 accepts a proton, so it acts as a base. According to Lorentz-Bronsted concept of acid and bases, an acid is a substance which can donate a proton and a base is a substance which can accept a proton. So here H2SO4 acts as an acid and HNO3 acts as a base. So H2SO4 by donating a proton to HNO3 becomes HSO4 minus and HNO3 by accepting a proton from H2SO4. That means proton here means H plus. By accepting a proton from H2SO4 it becomes H2NO3 plus. So the in this first step HSO4 minus is formed. This will act as a base in the third step. Then H2NO3 plus, that means protonated nitric acid, will dissociate and form H2O and NO2 plus ion. That means this is nitronium ion. This is the electrophile in nitration reaction. So what is the electrophile in nitration reaction? Nitronium ion or NO2 plus. Electron deficient species is electrophile. Then so first step is the formation of the electrophile nitronium ion. Then second step, it is the formation of the rhenium ion or carbocation or sigma complex. Nitronium ion, that is NO2 plus, that is the electrophile, attacks benzene to form a carbocation, also known as rhenium ion, also referred to as sigma complex, which is stabilized by resonance. This is the rate determining step of the process. So in the second step, the electrophile NO2 plus attacks on the benzene ring. So when this attacks, this electron pair will shift to this double bond electron pair will shift to this carbon. So this carbon will get a negative charge and at the same time this carbon will get a positive charge. Onto this negatively charged carbon, this electrophile will attack. So the charge of this carbon and the charge of the electrophile will get neutralized. So there will be a sigma bond formation between the carbon and NO2 group. Then there is a hydrogen atom on this carbon, and there is a positive charge formation on this carbon. So the aromaticity of this benzene ring is ruptured in the second step. So this electron pair can shift and different resonance structures will be obtained for this carbocation. Carbocation means this positive charge is on the carbon atom. So this is also known as an arenium ion or carbocation. Arenium ion means this positive charge is in a aromatic ring. So this is also known as arenium ion and also carbocation and also sigma complex because of the formation of a sigma bond between nitro group and carbon atom. So these are the resonance stabilized structures for the carbocation. This is the resonance hybrid. General way of representing these resonance structures, that is resonance hybrid. Positive charge is delocalized on this carbon and this carbon. So in the second step there is a formation of arenium ion. Then in the third step there is a loss of proton from the sigma complex. So HSO4 minus present in the reaction mixture abstracts a proton from the carbocation and restores aromaticity to the ring to yield nitrobenzene. So in the third step, HSO4 minus obtained from the first step will act as a base, and that will abstract a proton from the carbocation. That means HSO4 minus takes this proton, then forming sulfuric acid, and this electron pair will shift to this bond and form and retains the aromaticity, and this nitro group will get attached on this carbon forming nitrobenzene. So this is the mechanism of nitration reaction. First step involves the formation of electrophile NO2 plus ion, that is nitronium ion. Second step is the formation of arenium ion, that is also known as carbocation or sigma complex, and third step is the loss of proton from the sigma complex and finally getting the electrophilically substituted nitrobenzene. Next we are going to discuss about sulfonation reaction. So what is sulfonation reaction? Benzene when treated with fuming sulfuric acid. Fuming sulfuric acid is also known as oleum. Oleum means which is concentrated sulfuric acid additionally containing dissolved SO3. That means oleum is made by dissolving sulfur trioxide SO3 in concentrated sulfuric acid. At ordinary temperature yields benzene sulfonic acid. So benzene when reaction with fuming sulfuric acid, the product is benzene sulfonic acid. This reaction is called sulfonation and also occurs with concentrated sulfuric acid but more slowly. That means this reaction sulfonation reaction usually occurs with fuming sulfuric acid, but this reaction can also occur with concentrated sulfuric acid, but the reaction will be very slow. Why it is called fuming sulfuric acid? Oleum is known as fuming sulfuric acid. Oleum means a solution of concentrated sulfuric acid which contains dissolved sulfur trioxide. So on contact with air, oleum liberates the dissolved sulfur trioxide. Then when SO3 exposed to air, it rapidly takes up water from the atmosphere. It means moisture or any water vapor. Then and it gives off fumes, white fumes. That is why the name fuming sulfuric acid. So usually we use fuming sulfuric acid for sulfonation reaction. So simply we can say sulfonation is the replacement of a hydrogen atom in a molecule by a sulfonic acid group, that is SO3H group. That is sulfonation reaction. So benzene on reaction with sulfuric acid, one of the hydrogens will get replaced by a sulfonic acid group SO3H, and we will get benzene sulfonic acid. Hydrogen from benzene will react with OH from sulfuric acid and water molecule will get eliminated and benzene sulfonic acid will be formed. So here sulfonic acid can be represented as HOSO3H. Then final product will be, in this case final product will be benzene sulfonic acid. Then sulfonation is a reversible reaction, and irrespective of whether it is carried out with concentrated sulfuric acid or fuming sulfuric acid, the electrophile appears to be sulfur trioxide. So in this case the electrophile is SO3, sulfur trioxide, and also the reaction is reversible. In the case of sulfonation reaction, the reverse reaction is occur in a reversible manner. Now let us discuss about the mechanism of sulfonation reaction. The sulfonation reaction mechanism is somewhat different. It involves mainly 4 steps. So all the steps in the mechanism for sulfonation of benzene involve equilibrium, and as a result the overall reaction is reversible. So in this case all the reaction steps are reversible. So first step is always the generation of the electrophile. The electrophile SO3 is produced in concentrated sulfuric acid by the following manner, in which sulfuric acid acts both as an acid and as a base in its autoionization. So the electrophile is SO3. It is produced in the first step. In fuming sulfuric acid, this step is unimportant because the dissolved SO3 can react directly. So when we use fuming sulfuric acid, there is already SO3. So we don't need to produce SO3. So first step is unimportant in the case of fuming sulfuric acid. But when we use concentrated sulfuric acid, we have to produce the electrophile SO3. So sulfuric acid reacts together. So one molecule of sulfuric acid will act as an acid and other molecule will act as a base. According to Lorey-Bronsted concept of acids and bases, an acid is a substance which can donate a proton, and a base is a substance which can accept a proton. So here when this H2SO4 donates a proton to another molecule of sulfuric acid, it will become HSO4 minus. Then when this H2SO4 accepts a proton, this acts as a base and becomes H3SO4 plus. Then this protonated sulfuric acid will dissociate into H3O plus and SO3, the required electrophile. Usually electrophile will have a positive charge, but sometimes there will be no charge, but at the same time it will be electron deficient due to some other reasons. Here some other reasons means because of the electron deficiency in the structure. Because of the electronic nature of other atoms, neighboring atoms, it will become electron deficient. So one of the electrophiles without positive charge is sulfur trioxide, SO3. So in sulfonation reaction, the electrophile is SO3, that is produced in the first step. In the second step, there is formation of rhenium ion or carbocation or sigma complex. So the electrophile SO3 attacks benzene to form a carbocation, generally referred to as sigma complex, which is stabilized by resonance. This is the rate determining step of the process. So in the second step is a slow step, so it is the rate determining step of the process. So in the second step, the electrophile attacks on the benzene ring. So when it attacks, this electron pair will shift to this carbon. So see, this carbon becomes negatively charged. Onto this negatively charged carbon, SO3 will attack. So SO3 will get a negative charge. Then there is already one hydrogen atom on this carbon, and this carbon becomes positively charged due to the shifting of the electrons. So there is resonance stabilization again, resonance stabilization of the carbocation, formed carbocation. This is also known as sigma complex because there is a formation of sigma bond between carbon and SO3 minus. So this is the resonance hybrid of the resonance structures. So in the second step, it involves the formation of the sigma complex or rhenium ion or carbocation. Now let us know about the electrophilicity of SO3. The electrophilic center in SO3 is a sulfur atom on account of the higher electronegativities of the 3 oxygen atoms surrounding it. So SO3, how the SO3 molecule becomes electrophile? That means in SO3 there are 3 electronegative oxygen atoms. Because of its high electronegativity, there is charge separation. That means it becomes highly electrodeficient. There is partial positive charge on the sulfur atom. There is negative charge on the oxygen atoms. There are 3 such oxygen atoms, highly electronegative oxygen atoms. So the central sulfur becomes electron deficient. That is why it acts as an electrophile, because of the electron deficient nature that is obtained because of the presence of 3 adjacent oxygen atoms, electronegative oxygen atoms. Then the mechanism of sulfonation involves mainly 4 steps. 2 steps we discussed. Then the third step is the loss of a proton from the sigma complex and forming loss of a proton from the sigma complex, that is carbocation. Then HSO4 minus present in the reaction mix, that is obtained from the first step, abstracts a proton from the carbocation and restores aromaticity to the ring to yield the benzene sulfonate ion. So in the third step, the HSO4 minus ion that is obtained in the first step, that will act as a base and that abstracts a proton from the carbocation. Then when it abstracts a proton from the carbocation, it will produce sulfuric acid. Then when this bonding electron shifts to this carbon, the lost aromaticity will regain in the third step and producing a benzene sulfonate ion. An ion is produced in the third step. So in order to get a neutralized benzene sulfonic acid, there will be a fourth step, that is acceptance of a proton. Benzene sulfonate ion accepts a proton to become benzene sulfonic acid. So benzene sulfonate ion accepts a proton from H3O plus, that is obtained in the first step of the reaction, then forming benzene sulfonic acid. Then all the steps are reversible in sulfonation reaction. There are 4 steps in the sulfonation reaction. You have to remember that in chlorination and nitration there are only 3 steps, but in the case of sulfonation the electrophile is different, that is SO3 is the electrophile, and at the same time there are 4 steps in the mechanism. So today we discussed 2 mechanisms, mechanism of nitration and sulfonation reaction. So you have to write the mechanisms and practice. You have to be thorough with the electrophile. What are the electrophiles in each reaction? Thank you.